hope you'll find today's webinar useful. It will be entirely dedicated to rendering with V-Ray for Revit. We will start with exploring its main advantages, then I will walk you through the UI and the main features, and I will show you step by step how to render an outstanding image following a few simple principles. So, starting with this, V-Ray is a rendering plugin which has a solid position in the architectural world. 92 of top 100 architecture firms in the world use it on a daily basis. V-Ray is compatible with many host applications like 3ds Max, Maya, SketchUp, and many more. And what makes V-Ray in Revit different is that here we followed another design philosophy to make it as easy as possible, yet powerful and fast. It is a result of hundreds of interviews with architects and designers. And for all of them, visualization is not a primary focus, and they treat it as one tool among many in a large toolkit. Therefore, they need to be able to render in the most accessible way that is not time consuming in terms of learning and setup, and thus led by the idea to help designers achieve maximum results while putting as less effort as possible. We had to combine power and simplicity in a new way. So we took this. This is how part of the V-Ray for 3ds Max interface looks like. It is super powerful. It is great for visualization experts, but it is not easy to start using it straight away. I have also used it along with Revit. And I can say that even if you have the time to invest into learning, reloading the Revit model on any update is quite annoying. So we took all this and we created this. Same core, same power, less settings. A rendering plugin which installs as a seamless part of the Revit environment. This basically means that you don't have to struggle with intermediate software and to reload your Revit model thousands of times. Everything you need fits within this toolbar and respectively within the Revit workflow. Under just a few buttons, you have everything necessary to create a beautiful image. Most of the 3ds Max settings you saw on the previous slide were optimized and hidden from the interface for easy and smooth interaction. The render quality, however, remains the same as in 3ds Max because under the hood, the V-Ray render engine is the same. For me as an architect, the greatest advantage of having V-Ray and Revit is that its tools can be utilized at any stage of a design process and can help in solving design problems, evaluating design options, or presenting design ideas in the best possible way. On this slide, we see a stylized image which can be generated in a few clicks at an early project stage. And if we get more advanced, here we have another example. And VR panoramas like that one can also be rendered. They are very impressive from a client's point of view as they create a strong feeling how the actual building will look like before being built. Yet from an architect's point of view, I find VR quite useful in cases when you need to explore the space in terms of room measurements, when you need to evaluate specific distances like ceiling heights, railing heights, and so on, as well as if you need to evaluate the light in a room, the window size and positioning, and so on. So it's time to jump into Revit, and I will walk you around the main UI components. Okay, I'm using the basic sample project on purpose because all of you have it, and later on you can try to experiment what we have learned here. Initially, the toolbar is disabled, so the first thing that you need to do is to enable it. And enabling it means that you're engaging your license. Using this switch here, allows you to share your license across multiple machines. A few words with regards to licensing in general. V-Ray for Revit uses an online license server. This means that you don't need any physical devices to be plugged in your machine. You only need internet connection. And even if you don't have internet all the time, there is an option to borrow your license for a short period and use it offline. At any time, you can launch the online license server in your web browser. The easiest way to do this is by clicking the license server button. And here we are. Here you can see the version of your license server, as well as the list of all your available licenses. You can click on the corresponding V-Ray product, and here you see info about the number of licenses and which ones of them are engaged. Back to Revit. Let's look at the toolbar buttons. Clicking some of them launches additional windows. So let's start from left to right. We have the current view first. You can find a list of all 3D views existing in the project, and you need to select which one of them you would like to render. Then we have the render button. And the V-Ray frame buffer window where the rendered image appears. Uh, they're followed by the quality and resolution controls. Initially, when playing with the rest of the settings, I keep both of these to lower values. Otherwise, the quality drop-down contains quality presets from draft to very high. While the resolution button launches this window where you can set up the image resolution. It can be either in pixels or in print units. And by default, the aspect ratio is set to crop region so that you can render exactly what you see through the Revit camera. The next three panels uh, contain the lighting, assets, and camera controls. Um, we will explore them in detail later on. And since I have already set up the current view, quality and resolution, I am ready to run a rendering and play with the rest of the settings at render time. In V-Ray for Revit, there are two render modes, production and interactive. In interactive, we can see every change that we make in real time. That's why I will run interactive now. For some reason, the frame buffer appeared on my second monitor. This is the rendering progress window. Here you can see some messages in case of errors and so on. You can look for them right here, but now I will move it to my other monitor so that we have more space. Okay. A few words about hardware. V-Ray is flexible to render utilizing either the CPU or the GPU, or to use them both in a combination. Therefore, depending on your machine, you can set up your own preference. Simply, you need to go to Settings. In the Renderer tab, under Engine, you can select whether to render using the CPU or the GPU. In my case, I have kept this to CPU. Okay, so there are three main components we need to play with: lighting, camera, and materials. And we will start with exploring the relationship between lighting and camera. But before doing that, in order not to be distracted by the materials, I will open the asset browser and I will do a global override of all materials. This happens from the Global Materials tab. We have controls to override all opaque, transparent, or RPC materials with a plain color or with a V-Ray material. Simply enable the override. These features are great for exploring a project at an early stage, for massing, lighting, and spatial studies. In my case, I use them as a starting point for setting up my lighting and camera. And after I set them up, I will continue with the material setup. So V-Ray takes the sum position from Revit. So if we play with the sum position in Revit, our image will update in real time. I will change the azimuth and altitude, click apply, and now let's focus on the exposure value. It is part of the camera parameters. The exposure value is a number which is photography specific. It depicts the relationship between the camera shutter speed and f number. Well, it is not necessary for you to be a photographer in order to understand how it works. It is as simple as this. So the greater the value, the less light we let enter the camera, and thus the image gets darker, while the smaller the value, it is the opposite. So greater values are suitable for sunny and bright scenes, while smaller values are more suitable for either interiors or night scenes. So I will set this to 13.5. And the white balance, it also works as in a real-world physical camera. In some situations, depending on the lighting, the white color on an image might appear warmer or colder. Starting from the white color, this actually affects all colors on the image. The white balance can help you set up the correct white color for your image to make it look natural and realistic or more artistic as well. For now, I will keep it to its default value. And now let's look at the V-Ray sun settings. They are a great addition to the Revit sun settings because here we have controls for the sun visibility, the sun intensity, the size of the sun, which is related to the shadows. At the moment we see quite sharp shadows, but if we set the size to 10, this will blur the shadows. And now let's focus on the albedo controls. Uh, Definitely these settings are my favorite ones. The color of the ground or the color of the horizon is controlled by the albedo color. So we can finally change this grayish color that appears on the Revit's horizon. I will select a color. Please mind that this color will affect the GI a lot, so be careful when you choose it. And then we have the blend angle, i.e. This is the portion of the sky where it is blended with the albedo color, and if we increase the angle, the color will be more visible. We can also shift the albedo up and down using the horizon offset parameter. So if I set this to 5, probably something larger like this. Another option for environment lighting is the V-Ray dome light. It will create an imaginary dome above the entire model. The dome can emit light either in a color or it can be mapped with an HDR image and to emit light based on the image while also creating a picturesque background. So here's how it works. I just switched from sun to dome light. And I can play with the intensity and color. So if we increase the intensity, the image gets brighter, or we can change the color. This will affect the entire image. Let's take this here. And now I have an HDR image, which I will just drag and drop. Drag and drop it over the dome light window. And I will now need to adjust the exposure value and the white balance once again. So opening the exposure settings, and I will change the white balance to 'kay, and the exposure to, let's try with 12.5. Okay, now going back to the asset browser, there we are. The asset browser helps you manage your V-Ray assets in the rendered project. We have already explored the global materials tab. Now I will turn off the global overrides and I will go to the material map tab. In the material map tab, there is a list of all Revit project materials. The AutoGen tag next to each material means that V-Ray is using the native Revit material and automatically converts it to a V-Ray material at render time. From this drop down, we can switch to a simple color or simple texture material, or we can switch also to V-Ray material. Here is the time to say that V-Ray installs along with a library of over 550 ready-to-use V-Ray materials organized in 20 categories suitable for architectural visualization. So let me first show you the library. You can find it in C program file scales group V-Ray, V-Ray for Revit, VRMAT editor materials, and here we have the categories. So what will I do is that I will just select a few materials and I will drag and drop them over. So I will need glass. I will also need grass. And I have actually created a roofing material which is not in the library. here. Okay, I will also need wood planks. So let's go to wood and laminate. Now, after that we have assigned materials, we need to adjust the sample size width and height and the rotation. And I will leave the main building material as AutoGen, and now I will open the Revit material browser and will show you how material changes that are done within the Revit material browser are also supported by V-Ray. And basically, after changing this material over here, the rendering will update. I'm changing the map size very fast. And I will also darken the image like this. Click apply. And the rendering updates. I will also add some relief. And we have set up the building materials. Now, one thing that I see is that after we added the HDR image, uh, we basically can't see anything here on the horizon. So if I go back to the dome light controls, and here we have two options for adjusting the HDR. One is to rotate it horizontally, but the other one that I need is the vertical offset. Basically, this helps us adjust the horizon because, as you can see on the image preview, there is a horizon which I want to make visible on my image. So I will set this to -2. We are able to see it here. I think it is too high. That's why I will use a lower value. And the next thing that I see is that the grass is too dark and it doesn't go smoothly to the horizon. We have this line here. So what I can do is that I can modify the grass material. I forgot to adjust the map sizes, so I will do it very fast now. So besides the material library, V-Ray for Revit installs along with a powerful standalone material editor. It can be used both for modifying existing V-Ray materials or for creating new ones from scratch. Next to each V-Ray material, you can see this tiny button which will open the material in the V-Ray material editor. So we are now at the grass material, simply click here. And here we are. So the editor is simple. It is organized in two tabs, basic and advanced. In most of the situations, using the basic tab would be enough. There are also material presets to start from and to continue modifying the material. So what will I do right now is that I want to color correct the texture that we use for the grass. So I will go to the diffuse slot. Here is where we have the texture. And I will right click and I will copy it. Then I will go to the texture menu. The texture menu is accessible from this button here. And here we have a variety of procedurally generated textures which can help you simulate different materials like tiles, leather, marble, and so on. You can also mix textures. In our case, we need the color correction. Here it is. And here in the color input slot, right click, paste as copy. And here is our grass texture. Now here we can adjust the hue, saturation, and tint. I have set up the settings in advance, so let me just type them in. Okay, we're set up, and if I now go back and I save the material, well, I think that I would like to save it separately because otherwise I will override uh, this library material. So let's save it. So after I have saved it, I can just drag and drop the preview and place it on top of the grass material in the V-Ray asset browser. And our grass has updated, but still it is not a real grass. And what we can do now is to go to the V-Ray Fur tab. V-Ray Fur, as the name suggests, allows for making any Revit material fluffy. So in exteriors, you can use it to simulate grass. In interiors, it can be utilized when rendering carpets, cushions, blankets, and so on. the fur is applied to a material. If you want to cover with fur only a specific geometry in your project, make sure this geometry is assigned with a unique material. Select a material from the list and click the checkbox to add fur to it. I can just type in grass in the filter field. So here we have only the grass. Click enable and this will generate grass. A few tips. Avoid adding grass to very large topo surfaces. This may decrease performance. Besides, fur is for adding detail at areas that are closer to the camera. Far away from the camera, that detail is barely noticeable. Therefore, either split the topo surface and add fur only to the area that is close to the camera, or use the level of detail parameter. It conserves memory by decreasing the detail at the remote areas. We need to set up a start distance. The start distance is measured from the camera, and further from that distance, the level of detail will be applied by decreasing the fur density and increasing strand thickness. And the level of detail will be applied at a certain proportion specified by the rate parameter. Here is how it works. In our case, this means that starting at 25 meters, the fur will be decreased, the fur density will be decreased 2 times, and the thickness will be increased 2 times for every 15 meters. So on every 15 meters, decreasing the density 2 times and increasing the thickness 2 times. Now to add another dose of realism to my image, I will go to the RPC proxies tab and I will replace the existing RPC vegetation with the more advanced V-Ray proxies. So what are proxies and how to create them? V-Ray proxies are files of the VR mesh format. They import complex high-poly geometry at render time only. The geometry does not use up any of the Revit project resources as it is not present in the project. It appears only on render time. And in Revit, we are unable to load proxies directly. Therefore, the RPC objects are used as stand-ins. Many users ask where to find proxy models, and actually, you can create them on your own, very easy, with the help of the Poly2VR Mesh tool. This tool comes along with the V-Ray for Revit installation, allowing you to basically turn any high poly model into a VR mesh file. Despite that it is a command line tool, working with it is really easy. I will show you now. I will stop the rendering for a while and will hide it. Now, to run Poly2VR Mesh, you need to go to C Program Files, Chaos Group, V-Ray for Revit Tools. And here it is, but if you double click on it, nothing will happen. You need to go at the address bar over here, click and type in CMD. Here is what opens. Just one moment. So here I have an obj file. I have taken a screenshot from 3ds Max to show you how it looks. It is a simple tree. So what will I do? Back to the command prompt, I will type in poly to VRMesh, hit space, drag the obj, hit space once again, and I will drag and drop it once again, but then I will change the name of the file. So basically you need to specify first the obj that is going to be converted, and then the path and the file name of the VRMesh that it will be converted to. So here I will write 3 VRMesh. Okay, and hit enter. And as you can see, here we have the tree. I will now close the command prompt. I will go back to Revit and we'll run the rendering again. And now I want to show you that if you select an RPC tree from the Revit view, like clicking this tree over here, we will see it separately in the list, filtered, and then I can simply drag and drop our tree here. This is expected result since proxies are exported from different 3D platforms with different units and coordinate systems. Sometimes they might be downscaled, sometimes they might be overscaled. And in our case, it is overscaled. So in the proxy controls, you can change the scale, you can flip the vertical axis, and you can rotate the proxy around its vertical axis. Okay, now next thing is that we need to assign materials to the proxy. I have prepared some materials in advance, but since many users are asking me how exactly to create 3 leaves, I will now show you. I have I have assigned the other RPCs with VIR meshes in advance, so the first I will enable them. Let's wait a bit for the rendering. And meanwhile, I will also enable the infinite ground plane when we go to V-Ray settings, environment, and here we have the infinite ground plane option, which basically creates an infinite plane that is fixed to the 0 level of the project. Uh, we will simulate lake with it. but I think that it needs to sink a little bit like this. Now let's open the leaves material. Here it is, and it actually consists of two very simple textures. One is the leaf, here it is, and the other one is in the opacity slot. This is the one that creates the actual leaves. It is a black and white mask. So what we can do here is that we can create autumn trees. We can use the same approach that we used for the grass. I will first copy the diffuse texture. Then I will go to the textures list, but this time I will select the mix texture. Basically, this texture creates a mix from two other textures based on a map, on another map. So under texture A, I will put the texture that we copied from the diffuse slot, and under texture B, I will paste the same texture, but I will color correct it like this. And yeah, something like this. Okay, back. And I have a grayscale map which I will use. And now playing with the mixed curve parameters, we can blend the two textures so that we achieve the result of an autumn leaf like this. I will need to save this material separately because I don't want all my trees to be overridden because all of them are using that material. So I will save it separately and I will assign it only to a few trees. Okay, I will pick a tree. And I will drag and drop our new material. Oops. Here. I will also assign it to the front tree. And in advance, I have created also another more material like this one that is more reddish, and I will now use it also for one or two trees. Let me just find it. Okay. So I will override part of the background trees with this more reddish material. It is more orange. Okay. Now, last thing, because I think that in a while we will run out of time and I really want to hear if anyone has questions. So our image is almost ready. So I want to focus your attention on the VFB itself, the V-Ray frame buffer. Shortly we call it VFB. Here you have useful options for saving out the image or adding it to history. You can launch the history panel from this button over here. So you can save the image to history and then compare it with other images. And here you have useful options for color corrections, and they allow you to adjust the image without opening it with any other application. So another really good thing is that you can save these color corrections and you can use them also in another project or save a few color correction presets and explore how your image would look like when using them. So I have saved my color corrections in advance and I will now load them. Here they are. And the image looks a little bit overexposed, so I will decrease the exposure value like this. So a quick summary of what we did so far. We explored the different render modes and render engines, as well as the relationship between lights and camera settings. We learned how to work with the asset browser. We familiarized with some V-Ray specific settings like proxies and FUR. We also learned how to do some basic modifications to existing V-Ray materials. We also learned how to post-process the image from within the VFB and to save color corrections for further use.